Okay, so the recording has been started. So we are discussing about Java 8 futures. Already we have completed what is Lambda expression and how to write Lambda expression, right? And we have also discussed about functional interfaces. So function interface is very easy, right? A single abstract method. Yeah, right. And any interface with only one abstract method is called as functional interface. And we have seen some examples also. And we also understood how to invoke Lambda expressions using functional interfaces. We have seen many examples. We have also seen these things in the collection. I mean, by using the collection framework as well, right? In the last class, we have discussed about the default method and the static methods in the interface. And what is a default method, right? If you want to add any concrete method, you can add any concrete method from in an interface from JDK 1.8 till JDK 1.7. Interfaces will not accept any concrete methods, but from 1.8 it will accept concrete methods, but that method has to be defined by a keyword called default, right? We have understood its implementation, we have understood how to use those concrete methods, and we have seen many examples on top of it. And also we have discussed how to override the concrete methods with respect to multiple inheritance and static methods as well, right? So any method, you can also write static methods, but the static methods cannot be overridden. The main purpose is they are used to define the general utility methods, right? If you want to call a static method that is part of an interface, you can just use the interface name followed by the method name, static method name. That's it. Right? Can we override static method interface? No, we cannot override the static methods in the interface. You can call it directly by using the interface name, right? So today the topic is going to be very interesting topic and very important topic for the interview purpose as well as for the real-time applications. So predefined interfaces in predefined functional interfaces in Java. The heading is predefined functional interfaces in JDK 1.8. So when the JDK 1.8 was introduced, they also introduced some functional interfaces, some predefined functional interfaces that can be used to fulfill the common requirements, right? So there are many predefined functional interfaces that you are going to see, but the most important ones are, you have a concept called predicate. So predicate is a functional interface, okay, predefined functional interface, and you have a functional interface called the name of the interface is function itself. These are the names of the interfaces, and you have interface like consumer is also a functional interface, and you have interface like supplier, right? And you have many interfaces, like it keeps going, but these are the common interfaces, and to fulfill the very common requirements, you can utilize these interfaces. First of all, we will understand the importance. We will understand how these interfaces will help us out in solving many common problems, right? First, we will go with what is a predicate. You may get a question in the interview room like, what is a predicate? Right? What is a predicate? What is a predicate? Right? So I can say that the predicate was introduced in JDK 1.8 version. Okay? It is a functional interface. It is a functional interface that was introduced in JDK 1.8 version, right? And it was introduced, it is available inside java.util.function. There is a package called a function package. In this library, you can find the predicate interface. It is available in java.util.function. Okay, and it has only one abstract method. It has, and because any interface, if you are saying it is a functional interface, it means it has only one, it will have only one abstract method. At least it should have only one abstract method. That abstract method is called as what? In this case, in this case, the predicate has only one abstract method. The name of the method is test method. Is test method. So by definition, any interface has to have at least one abstract method. Likewise, the predicate, I have just defined the predicate as a functional interface. So what does it really mean? It should have at least one abstract method. Okay, that abstract method is called as what? The test method. Okay, and the fourth point is the prototype of the method could be like this, guys. Interface predicate, and it is going to accept any kind of data type, any kind of argument, and the return type is always boolean. The name of the method is test T. Right? This is the prototype of what? This is the prototype of the test method. Okay, the fifth point can be it is used extensively in functional programming. Okay, we will see about the functional programming, more about functional programming going forward, and stream operations. We will also see about what are the stream operations. Okay, this is all about the I cannot say it is definition. It is all about the points for the predicate. Okay, if someone is asking you what is a predicate, so you can answer these 5 points. That's it. So we'll understand more about predicate. So this is the prototype. So this is the prototype of the predicate. Why the prototype is like this? See, let us understand that. So when I say this is the prototype, when I say this is the prototype, and if you see, I can say that this is a functional interface. Why I can say that this is a functional interface? We change the prototype. It should be boolean. Okay. When I say that this is a prototype for the of the predicate, now you see, guys. Okay, so this is a functional interface. So when you are defining an interface as a functional interface, it should have only one abstract method. So in the predicate, you have only one abstract method. No matter how many default methods you are going to have, how many static methods you are going to have, that is not the criteria to define an interface as a function interface. The criteria is it should have only one abstract method. Right? So the predicate has only one abstract method. The name of the method is the test method. The name of the test method is a test method. So it is like, see, this is the name of the interface predicate, right? And it is accepting some kind of generic parameter. So when you see something enclosed inside the angular braces, right? So it is mentioned as T. It is mentioned as what? It is mentioned as T. It means you can pass any type of parameters. So you can define, or you can say that you can place any kind of data type here. For example, if you say integer, okay, the input type would always be integer. The parameter that you're going to pass, that it is going to accept, would be integer. If you say the input type is string, it would be string. If you say input type is boolean, okay, it would be boolean. So wrapper classes. If you say the input type is float, it would be float. If you say the input type is something like any user defined data type, it should be the user defined data type. So the input can be anything. Input can be integer, input can be a string, or it could be boolean or float, right? So whatever the input that you are placing it here, okay, that data type will be passed as an what? That data type is going to be passed as an input. That data type will be passed as an input, right? So the input can be anything, but the output is always boolean. Try to understand. You can define, you can make sure that this predicate is accepting any kind of input data, but the output is going to be what? It is going to be boolean type always. So after accepting these inputs, it will, you have to write your own method. You have to write your own method, and you have to define your own implementation. You have to write your own logic, and after completing, after completing the functionality of that logic, it should return either true or false. The output should always be boolean. It is just like this. You need to construct, you need to override this method in such a way that you are going to define your own logic. So this logic will be written by you. This logic will be written by you, and you are allowed to pass any kind of input. You are allowed to pass any kind of input. Right? You're allowed to pass any kind of input. The input can be the string type or integer type or float type or any user defined data type. But the output should always be what? Output should always be either true or false. True or false. Right? So the logic should be written in such a way that it should return either true or false. So you can write your own logic. I mean, you can define your own functionality so that the output is always true or false. We'll understand these things in some examples. Right? Now, what is a predicate? You can say that it is a functional interface. It was introduced in JDK 1.8 version. It is available in this package, and it has a test method, and this is the prototype, and it is used in functional programming and stream operations. Right? But the question is how to use this predicate. How to use predicate. So this is the question that is triggering in your mind now. Okay. Usually, you can use this predicate to refer lambda expressions. So I can say that please be informed that you can use this predicate to refer what? To refer lambda expressions. So we already know how to refer lambda expressions. Okay, let us write a small code on top of this. So let me go back to the paint screen. Okay, so let me take a class case, a simple class. Okay, let me increase the font size, or else let me go to the editor and write a class. So I have a driver class here. Focus here. I have a driver class here, right? So without using lambda expression, I want to utilize the functionality of the predicate without using the lambda expression. So this is going to be what? Without using lambda expression, right? So how can I write? I want to I want to utilize the functionality of the predicate. So my class needs to implement the predicate interface, right? I need to make a contract between my class and the interface, which is predicate. So predicate is already available inside the JDK 1.8 library. So what I am doing it here, I am using the implements keyword. Okay, I am going to implement the predicate. See, if you see predicate, if I am implementing predicate, it is showing it is available in java.util.function package. I need to import that because I am utilizing the existing library. I'm utilizing the existing functional interface which is available in java.util.function package. So I need to import that. Right now it is asking me the type. It is asking me the generic type. Let me take the generic type as integer. Focus here. Let me take the generic type as integer. Okay, let me maximize this. Okay, I have taken the generic type as integer. So my class is implementing the predicate interface. So far, good. Right now, what I want to do. So what is the rule? Whenever a class is implementing an interface, it should override the abstract method. So what is the abstract method that I have just said? Test is the abstract method that is there inside the predicate. Yes or no? Right? So I need to override the unimplemented methods. So this is how I'm using the shortcut. So this is how. There is a method called test method. Okay, test method. So you are passing integer here. Okay, it will accept the input type as integer only. If you pass string here, okay, you should use string here. If you pass any other data type here, you should do that data type here. So for the time being, I am taking as integer. For the time being, I am taking what? I am taking as integer. So my intention is I want to write a program. I want to write a simple logic, guys. I want to write simple logic if a given number is greater than 100 or not. What is my logic? Write a logic to check if the given number is greater than 100 or not. If it is greater than 100, my method should return true. If it's not, my method should return false. How I can write that logic? Okay, I can use what? I can use an if condition. Let me minimize this. Okay, I can use an if condition. If, okay, so this is where I am accepting the input. If t is greater than 100, if the number that you are passing is greater than 100, return true, right? Else return false. That's it. So I have written a logic. What I want to do? So my intention is I want to write a function. I want to write a function in such a way that the number that I am passing is greater than 100 or not. I want to check that by using the test method. Okay, so I will pass a number inside the argument. Okay, and it will collect this number and it will check if it is greater than 100, it will return true. If it's not, it will return false. So how this logic is going to work in the real time? How this logic is going to work? So this is our method. So this is our method, and you will do what? You will pass something like, for example, let us say that you are passing something, a number like, let me minimize this. It's very big. Let us say that you are passing a number something like 1000. Okay, so 1000 will go as an argument. So t will be replaced with 1000, right? So now as soon as the execution starts, this 1000 will be tested in the if condition. If 1000 is greater than 100 or not. Yes, it is greater than 100. So this condition is satisfied. So true will be returned. So true will be returned to you. So the output is going to be what? The output is going to be, right? For example, let me say that I am passing 10 second time. So this 10 will go as an argument. Okay, and firstly the if condition will be checked. If 10 is greater than 100, no, it is not, then the else condition will be returned. So false will be returned to the console. Else condition will get executed in this scenario, right? So false will be returned. So whatever the input that you pass, the output is going to be either true or false. Apart from this two, you are not going to get anything, right? Apart from this two, are we going to get anything? Either you will get true or false. So that's why the return type is always boolean. Okay, so you are asked to write a logic in such a way that your logic should work in such a way that your logic should return the output in the form of true or false. That's it. Input can be anything. You can choose to pass numbers as an input. You can choose to pass a string as an input. You can choose to pass the user defined data as an input. This input, the input that I am talking about, this could be anything. Input can be anything. The output has to be either true or false. It's up to you. You need to write a logic in such a way that it is returning true or false. If you find such requirement, then you can go for predicate. So what did I just say? Like if you get any scenario, okay, the output has to be the boolean type. First thing, the output has to be the boolean type, but the input can be anything. Okay, and if you have such requirement, blindly go for predicate. What is it now? I think you have got some idea. Predicate. Whenever you feel like to choose predicate, whenever you want to choose predicate, just try to check if this is filling these two criteria. What is that criteria? Output must be either true or false. Okay, and the second criteria is input can be any data type. Can be any data type. Okay, if this is the requirement, right, you can just directly jump and write a logic in the predicate interface. Right? Okay, we have written the logic. We can return the logic. How can we execute this? We know how to execute this. What we usually do, okay, what we have been doing so far for the execution. Let me. This is without lambda expression. The logic has been written without what? Without lambda expression. Right? Okay. So what I want to do here, I want to call this method, right? I want to call this method. Logic is written, but I want to utilize the logic by calling that method, right? So how I can call the method? Use the interface name, which is what? Predicate. Okay, of what type? Integer type. Okay, and I am taking the variable name as p equal to new driver. Right? So object can be created for class, but not for the interface. So this is an interface, remember. This is an interface. So I cannot create an object for the interface. So I can create an object for the implementation class, because driver is implementing predicate. So predicate has been kept as the data type, and object is created for the class, implementation class. Right? Polymorphism concept. Since you cannot create an object for the interface, I can use the type as interface type, and the object can be created for the implementation class, which is driver class. Right? Now what I want to do after doing this, system.out.println, by using this reference variable p dot, okay, what is the method that we have here? Test method, right? Test. You can pass any number. If you pass 1000 here, okay, it should return either true or false. Right? Output is true. Okay, let us find the second case. If I pass instead of 1000, if I pass 10, second case, if I pass not one, third case. Okay, the inputs are always integer, the output is either true, false, or true. Our logic is working perfectly, but this logic has been written without using the lambda expression. Right? Without using the lambda expression. We know what is lambda expression. We can take advantage of lambda expression, right? So this has been written without using lambda expression. I want to write the same logic by using the lambda expression. How we can write it? It can be simplified very easily, guys. Let's see. It will be like how this code has been simplified further. Okay, this is our actual code without lambda expression. Focus here. This is without what? Without using lambda expression. Right? I want to use lambda expression. How I can use? Okay, directly let me jump to the main method. Directly let me jump to the main method. Right? So if I want to use lambda expression, focus here. Implements predicate. This is not required, first of all. Okay, directly I can have what? Directly I can write public. Let me increase the font size. Public class driver. You do not want to implement it, first of all. Right? The second, if you are not implementing it, you do not want to override this method. Second part, you do not want to override. So this is also not necessary. These are the unnecessary things if you are using the lambda expression. Unnecessary things. Right? Directly you can do what? You can write the logic inside the main method. In this scenario, public static void main string array ops. Right? Directly write the main method, then use the predicate, because it is already there. Okay, you are going to import it in the, which is inside the function util.function package. Integer p equal to, right? So let us understand this in the program. what I'm trying to say is this is not required. So this is without using lambda expression. I want to use with lambda expression. By using lambda expression, right? Implementation is not required. So I'm removing this. Or instead of removing this, let me remove this. This is not required. Okay. Instead of writing all this, I can directly write the implementation. I can directly write the implementation where? Here. Directly I can write the implementation here. Okay, this is not required. Let me repeat, this implementation is not required. Instead of writing it here separately, I can directly write it. I can replace this new driver. I can directly give the implementation here. Okay, and I want to do what? I want to convert this to the lambda expression. I want to convert these lines of code into the lambda expression. To convert this line of code into the lambda expression, what I was just saying, we have been discussing this for a long time. Okay, access modifier is not required, and return type is not required. Okay, and name of the method is also not required. Okay, so between the parameters and between the body, you need to introduce an expression, or you need to introduce an operator called what? Angular operator, right? And need to place a semicolon at the end, right? So this is the code which has been simplified when you are writing that code in the form of what? Lambda expression, when you are invoking lambda expression. And I want to optimize this code further. If I want to optimize this code, I have been telling you, if you remember or not, when your parameter has only one data type. So in this case, our parameter has only one data type. So data type is also not required, because based upon the context, the compiler will recognize the data type. So I can remove this integer also, right? The second thing is, here you are doing the conditional check case. Here you are doing what? See, so let me copy this. Focus here. We are talking about the optimization. So this is completely valid, but I want to keep this code clear and concise. I want to optimize this further. I want to optimize this piece of code further. Okay, let me place it here. So this is the lambda expression. This is also perfect. I'm not saying that this is wrong. This is also perfect, but I want to do further optimization. Okay. First optimization I can do, right? Whenever there is only one parameter, that parameter is optional. I mean, that data type is optional. So you can reduce what? You can reduce it to T followed by, right? And the second thing is, in the body of the lambda expression, you are using if else condition. Focus here. In the body of the lambda expression, you are using what? You are using if else condition. Okay. Please remember, whenever you are using only if else condition, there is an if condition, there is an else condition. In the condition, there is only, you are checking only one condition, only one if condition you are checking, and inside this if block, okay, inside this if block, you are just doing what? It has only one line of code. Let me repeat. Inside the if block, okay, there is a condition. Okay, you are doing a condition check, and there is only one line of code. Return true. Return true is what? Only one line of code. Else, again in the else block, there is only one line of code. If you encounter this kind of code, sometimes in the if condition, you may be having lot of lines. If condition, there will be a condition here, and inside this if block, there will be number of lines. In that case, you cannot do anything. Okay, but in this case, the condition is only one condition you are checking, whether the number is greater than 100 or not. Okay, and there is only one line of code. That one line of code is what? The return itself is returning true. Even in the else, there is only one line of code that is returning false. Okay, if that is the case, you do not have to keep all the if else statement. You can just write the condition of if. What is the condition of if? P greater than 100. Okay, that's it. Okay, when you do this, when you keep this, the compiler will recognize, oh, okay, this is the if condition. Okay, this is the if conditional check. Okay, if the conditional check is returning true, it will return true. If the conditional check is failing, it will return false. What is happening here is, if you pass 100 here, Okay, this 100 will be tested. 100 is greater than 100 or not. It is going to return what? It is going to return false. Right? If you are passing 1000 here, 1000 will be checked. 1000 is greater than 100 or not. It is true. It will return true. Okay, so based upon the value that you pass, the condition will be checked. Based upon the output could be either true or false. So you do not have to keep all these lines. You can remove all these lines. Not necessary. You can keep only what? You can keep only the condition here. That's it. Only the if condition here. That's it. This if condition will take care whether to return true or false. This is how you can simplify the lambda expression. So by having said this, how I can rewrite this code? How I can rewrite this code? Okay, I can remove this data type. Not necessary. Okay, and check the if condition. If condition has only one line of code, that code is what? It is returning true itself. Even the else, it is returning false. If that is the case, you can remove all this. You can remove this if condition. You can remove this block. You can remove else block, and you can do what? You can remove this body. You can just keep this and place a semicolon. That's it. Lambda expression is simplified. Okay, and if there is only one parameter, these brackets are also optional. These parentheses are also optional. Optional. So this is only one conditional check. So this parenthesis is also optional. That's it. P greater than 10. That's it. If you run this code, you will get the same output. Now look at the lines of code without using lambda expression and by using lambda expression, how it has been simplified. See, without using lambda expression, so this is how the code was like. This is how the code was like. And by using lambda expression, you have converted this code. See, look at the number of lines. This is how it looks like by using lambda expression. Lambda expression. No worries, we will see few more examples. You will understand this better. Okay, so what I was saying, very simple. What is a predicate? It is a functional interface introduced in JDK 1.8. Okay, it is available in java.util.function package. Second point, it has only one abstract method, test method. Remember this test method. That's it. Okay, and remember this prototype. Always remember this prototype. Okay, this is how the prototype looks like. It is used extensively in this operation. So first example we have discussed. Example 1. Example 1, right? So this is how the example 1 looks like. I will see many examples. Okay, you will understand more about the interface. Okay, now in our example, I have used what? I have used something like integer. Okay, let us go back. Now I have a new requirement, guys. Let me remove all this nonsense. Okay, so I have a new requirement. My requirement is I will pass a string. I want to check whether the length of the string is greater than 6 or not. I will pass a string. Okay, input is string. Input is string, and the output should be what? Output should be true or false. So it should return true if it is greater than 6. If not, it should return false. Example, for example, if I take Ratna, the length of the Ratna is a string. The length of the Ratna is 5. Okay, and it should return what? False. Okay, if I take Ganesh, the length of the Ganesh is 6. Okay, it should return false. It should be greater than 6. If it is greater than 6, it should return what? It should return true. If I take Srikanth, the length of the string is what? 7. It should return what? True. This is my requirement. I hope you have understood my requirement. Okay, let us design a logic without using lambda expression first. Always we will try to write the logic without using lambda expression. Then we will start optimizing it. Right? So we are talking about predicate. So your class has to do what? It has to implement predicate. So input is what? Input is string. So here I will define it as what? String. Okay. And what is a contract? Whenever your class is implementing an interface, and if it is a functional interface, you need to give the implementation. You need to override the abstract method. What is a method? Prototype. Okay. So this is the prototype. Let me copy the prototype. Okay. Let me paste it here directly. Overriding. Okay. I need to override the method, right? So in order to override this, I need to give the implementation for this. So this is the abstract method. So you're talking about the abstract method. So this is not required. So I need to give the body. Abstract method. I need to give the body for the abstract method. Right? So T is what type? You're passing string here. So it should be what? String. Right? And it should return the output in the form of either true or false. For the time being, let me return what? Let me return false to eliminate the error. Okay, and it should be public. Done. Okay, but I did not give any logic here. Okay, it is accepting string inside. I need to check whether the length of the string is greater than 6. If it is greater than 6, it should return true, or else it should return what? False. Right? Keep that logic in the mind and write the program, build the program. Okay, if condition, if so you are accepting a string here, if t dot length is greater than 6, t dot length is greater than 6, return true, right? Else if it is not greater than 6, directly return false. That's it. This is the simple logic. So you're accepting a string here, guys. The string can be anything, Ratna or Ganesh or whatever it is. Okay, the logic is written in such a way that the first conditional check will check whether the given string is greater than 6 or not, whether the length of the given string is greater than 6 or not. If it is greater than 6, it will return true. If not, it will return false. Okay, so you're writing a program without utilizing the lambda expression. Always, since we are practicing this, always try to write the program without using the lambda expression. So the logic has been written successfully. Okay, I need to call this method. Okay, so predicate of what type? String type, isn't it? String, because input is string. Okay, here let me take p equal to new driver. Okay, so by using this reference variable name p dot test. Okay, so it is returning, right? So I need to include this in part. System.out.println p dot test method. So let us pass Ratna. First it will check this Ratna, the length of the Ratna is greater than 6 or not. If it is greater, it has to return true, or else it has to return false. Okay, it is not greater. Okay, and second case, Ganesh. Okay, Ganesh is also not greater, but it is equal to 6. So the condition is greater than 6. Length should be greater than 6. So it is returning false. Third one is what? Srikanth. Okay, and for the Srikanth, it is greater. It should return true. Right? So we have used this by using what? Without using what? Lambda expressions. Okay, let me keep this. Example 2, write a program using predicate to check whether the length of the given string is greater than 6 or not. Okay, so without using lambda expression we have achieved it. Without using lambda expression, this is how the code looks like. Let us simplify this code by using the lambda expression. Right? If you want to use lambda expression, this concept is not required. You can remove this. right? Instead of writing this here, I am cutting this, I am just removing this. Okay, I'm just removing that. I am directly placing it by removing this new driver. Okay, how to make this as a lambda expression? So access modifier concept is not required. I'm removing this. Okay, return type is not required. I'm removing this. The name of the method is not required. I am removing this. So between the parameters and the body, you need to place the arrow operator or the arrow token, right? And you need to place a semicolon. Okay, this is the valid lambda expression. I'm not saying that this is invalid. Even if you keep this, completely fine, you will get the same output. But I want to, if you want to optimize this, you can optimize this. Okay, how I can optimize this further? I want to optimize this. Okay, I have been saying, right, if the parameter has only one data type, okay, this is optional, you can remove this, right? I can place just t followed by the arrow token, right? In the previous example I was saying, if your if else condition, okay, if inside the body of the if condition, if it has only one return, only one line of code which is written itself, and in the else if it has only one line of code, that is the case, you can directly place this condition. This condition would this condition is more than enough. Condition is what? T dot length is greater than 6. Okay, this parentheses are also optional. So further simplification can be T arrow token T dot length greater than 6. That's it. Having said this, if I have to optimize this in the code, okay, so this is not required, right? Because the parenthesis, I mean the parameters, there is only one parameter. Okay, you do not want to define the data type. Data type is not required because based upon the context, compiler will recognize which is the data type, right? So inside the body of the if condition, only one return keyword is there. That is the case. This nonsense is not required. All these things are not required. Okay, only you can place only one, the condition itself you can place, right? And if you focus about the lambda expression, the body of the lambda expression, only one line again. This parenthesis is also not required. So only you can keep this. It should be terminated with a semicolon. That's it. I can simplify further. Okay, only one parameter, right? Only one. So this parenthesis is optional, right? And again, this is this logic is a single logic. It's not separated. It is everything is combined together to form a single logic. So it's also optional. That's it. We run this code, same output we are going to get. Predicate. Understanding this? Right. So this is with you by using lambda expression. By using lambda expression. Okay, one more example I will give you. So this time we will pass the collection. Okay, now this example, all your doubts will be cleared with these examples, guys. Trust me. Okay, this time I want to write a logic. Let me remove all this. Let me write it from the beginning. Okay, so I want to pass the object of the collection. I want to do what? I want to pass the reference variable of the collection. Okay, and it should return. It should return if the collection is empty or not. It should return true if it is empty, or else it should return false. Okay, what I mean, so this is I have decided to write a code. So implements. So our class has to implement what? Predicate. Every time whenever there is a requirement, check what is the question. Question is what? you will pass a collection. Input is collection type, output is either true or false. So blindly go for predicate. Implements predicate. So what is the input that you're going to pass? Collection object. So this should be what? Collection. Of what type? Collection type. Okay, and it is asking you. Okay, and you need to override what? You need to override the unimplemented methods. Okay, it is accepting a collection object, and you need to write a logic in such a way that it should return either true or false. Right? Same if condition. If p dot, there is a method called isEmpty method. P dot isEmpty method. If the collection is empty, okay, return true. IsEmpty method is part of collection, so you are using that method directly here to check whether the given collection reference variable is empty or not. If it is empty, you will return true, else you will return what? False. Okay, logic has been written successfully, right? And you're writing this code without using the lambda expression. Yes or no? Right? So predicate. So type is what? Collection type. Generic is not required. Okay. P equal to new driver. Okay. Now let us say that I have two collections, guys. I have array list AL equal to new array list. Okay, generic type is not required. New array list. So in this AL1 object, I am adding one number, AL1 dot something like 100. Okay, and the second one is AL. This is AL1. This is AL2. I have taken another collection. Okay, this time I am not adding any values to the second collection. So first collection, okay, first AL1 reference variable is not empty because you have added one number. Second AL2 connection should be empty because you are not adding any objects. No objects are added in this collection, right? So what you are trying to do, you are using this system.out.println p dot, what is the method? Test method. This test method is accepting two arguments. Firstly, you will pass a reference variable of first collection, AL1. This AL1 is empty. It is not empty because you have added one number. So it should return what? Return false because it is not empty. You have added one number. Okay, now I want to check AL2. This AL2 is empty. Yes, it is empty because you haven't added any number here. This AL2 is an empty object. Right? It should return true. Right? And even if you remove, if you decided not to add any number for the A1 reference variable, in the both cases it should return true only because both are empty. Both collections are empty. True. Right? What I am trying to say is you have an option to pass a collection object, right? And you can test the criteria by checking whether the collection is what? True or false. You are defining the logic by overriding the test method of predicate interface. Okay, this test method is accepting. Now this time the input is collection. Okay, this variable is tested whether the collection object is empty or not. If it is empty, return true, or else return false. Right? How I can simplify this for the lambda expression? Okay, for the lambda expression, these are unnecessary. You do not want to implement. If you want to write this lambda expression, you can remove this. Okay, this implementation can be directly given in place of, you can replace this new driver and you can give that implementation. Right? For the lambda expression, the access modifier is not required. Right? The return type is not required and the name of the method is not required. Between the parameters and the body of the lambda expression, just place the arrow token, right? And complete the lambda expression with a semicolon. So this is the complete lambda expression that you have. Right? What is the further simplification that you can do? If there is only one line in the if condition and only one line in the else condition that is written itself, okay, all these things are not necessary, right? And even this if is also not necessary. Even this if is also what? If is also not necessary, right? This body is also not necessary. You can place this with what? Semicolon, right? And if there is only one line in the body, you can place only one line. And if there is only one data type, the data type is also optional. You can remove this, right? Since there is only one parameter, these parentheses are also optional. So this is the simplified lambda expression. How many lines of code that we have? We'll get the same answer. Both are empty. If you add some objects, if you add al1 dot add some numbers here. Okay, now this time al1 is not empty, al2 is empty. So first has to return false and second one has to return true. False and true. If you add one more object, if you add an object for the al2 reference variable 200, both are not empty. So for both of the cases, it should return what? False. Okay, this is how the code looks like. Okay, so we will see many real-time examples on top of the predicate concepts, right? Try to repeat this video once again with pen and paper. So whenever you get a question, just remember this. Okay, the intuition should develop you. Okay, whenever you get a question like whenever you get a question like the input, so you are talking about the input and the output. Okay, when they ask you okay, the input can be of anything. The input can be of what? Anything. Okay, any data type. You can if you are asked to use any kind of input, it can be string, it can be collection, it can be integer, anything, any input. Okay, but specifically for the output, when they are asking you to give the output in the form of a boolean expression, either true or false, true or false. Output is always boolean, but input can be anything. Okay, so you can do what? You can use predicate and you can design the logic inside the test method. Okay, so this predicate, the what we call it as the generic type, the input. So you will define the input next to the predicate, right? And it's up to you. The code should be written by you. So this is your job. You can design code in any way based upon the requirement. Okay, but the output will be in the form of boolean expression, either true or false, no matter what the input is. Okay, the input that you are talking about will be placed here. Output should always be boolean. That is the case. Directly use what? Predicate. You will write lot of codes on top of this predicate in the future topics. Again, I am repeating. What is a predicate? Okay, don't just blindly remember this 5 points. What is a predicate? It's a functional interface. Predicate 1.8 version. It is available in this package, java.util.function package. It has an abstract method called test method, right? And this is the prototype. Remember this prototype, because this is an abstract method. You are going to use it for overriding purpose. It is extensively used in functional programming and stream operations. So these are we have seen 3 examples. Example 1, example 2 is discussed, and the example 3 which I have just elaborated now. This is the example 3. I will place all this in the notes. the description in the YouTube. Okay, you can just do some practice on top of this. Okay, any questions for me that you have for the day? Do you have any questions? If not, we can wind up for the day.